We're at the Golf Ball Performance Lab where we test all the golf balls.
We take a lot of the key protocols from automotive industry QC or aerospace. We're proactive in the QC, so it's not an end result of QC, we're actually planning for it.
It's one of our standard COR cannons for the USGA initial velocity test. And we can actually vary the angle of the plate as well as substitute different groove profiles. And this is one of the ways that we prepared for the USGA groove rule change for 2010. Our Shore D hardness tester, and with a multi-piece ball, that hardness number is really what dictates the performance off of each club. 2 compression machines, one's a little bit more automated. All these different measurements have effects on performance. And with the hitting robot, we can simulate any golf swing, a side spin, back spin, launch angle, spin rate, as well as all the club parameters. This is where everything comes together, and we can validate all of those numbers. We can adjust the lie angle, the hip angle like this, the face angle here, and with those 3 parameters as well as the height of the robot, we can simulate almost any club. We really focus on ball velocity, launch angle, and backspin. And that's really what is going to categorize your different balls. We'll have 10 iterations for one product where we bring it back and then make a little tweak to the cover, or maybe a slightly different coating. So you can see how many different iterations of samples we went through for the crush ball. We've got probably the size of this lab of shelves of just old golf balls. So this is just in the last year basically, and we'll bring them up after that and archive them.
The machine behind me back here is our indoor test range, and basically what it allows us to do is take any golf ball, shoot it down the range at a different speed or a different spin, basically looking at everything from like a 60-mile-an-hour like women's driver shot up to like a Tiger Woods condition, 180, 190 mile-an-hour ball speed. So we know the time that the ball crosses each one of the light gates all the way down the range. We know the distance between the light gates. It's really allowing us to examine the aerodynamics in real-world situations. It hits the rotating belts, and because we can control the speed of each belt individually, we can put whatever spin we want and get it very accurately at the end. So we think that there's room to optimize dimple patterns and aerodynamics for the average player where we can really get something better for them. All right, so we're here taking a look at our new 3D scanner. So what this allows us to do is to build up a 3D image of the ball and of specifically one dimple. So we really want to learn how aerodynamics and dimple geometry is related. And so this lets us measure each dimple down to like the 1/10 of a micron. And we're hoping that learning more about how each shape affects the flight of a golf ball with the ITR and outdoor testing, that we'll really be able to design a better dimple because of that. And we hope that we can adjust the lift and the drag differently by tuning these different size roughnesses and different scales.
Where are the potential defects? How can they be addressed before these defects happen? How can we reduce the effect of these kind of quality problems in the future? So we're really kind of planning forward in terms of QC before the actual start of production happens.